Hi guys, today's video is going to be about graphing logarithms, and I'm going to start with graphing an exponential because we know that logs and exponents are inverses of each other. They undo each other, so that's why we've been going back and forth between log form and exponential form, is they are inverses of each other. And over here in the margin, when we talk about inverses, then when we're graphing, that means the x switches with the y. And also when we're graphing, it means we're going to reflect it over the line y equals x. And so let's take a minute to think about how to graph an exponential equation, and then we'll use that information and we'll use that to graph the log function. So our first example, 2 to the x power, if we take a negative 2, we're basically going to plug this in. And so you don't have to write this down, but just so you know what we're talking about, I'm talking about taking like 2 to the negative second power, 2 to the negative first power, 2 to the 0 power, etc. So I'm just plugging into this function the negative 2, negative 1, 0, 1, and 2. And I'm choosing these for my x values because I can. We can put negatives in there, and these are numbers that are easy to work with and easy to graph, so that's why I'm choosing that set. So 2 squared is, negative 2 squared is 1/4. Remember that negative means it's 1 over. 2 to the negative 1 is 1/2. Anything to the 0 power is 1. 2 to the first is 2, and 2 squared is 4. So now take a few minutes to graph those points. Okay, so your graph should look something like this. I went ahead and included the point 38 just because I knew that was my next point, and sometimes it helps to get a better idea of how steep to go if you have a couple more points. But some important things to notice. One is that we have a y-intercept at 0, 1. And we've been talking about that is supposed to happen, and it pretty much is supposed to happen all the time. The next thing is my next point is at the point 1, 2. That's because this has a base of 2. So my next point is at the point 1, 2. Okay, now that I've graphed that, I am going to do two things dealing with this information in the margin. For one, I'm going to reflect it over the line y equals x. So I went ahead and included that line. Also, I'm going to change my x with my y. So the same stuff I had in this table is also going to go into this table, except I'm going to switch my x values and my y values. So now I have my negative 2, negative 1, 0, 1, 2 over in the y column, and my x column is going to be 1/4, 1/2, 1, 2, and 4. Now, a lot of times, you might just have to do that every single time. I do that a lot. Instead of just jumping straight into this, you have to go back and think of, well, what was the exponential equation? And if I knew that exponential equation, then maybe I can graph my log equation. So now take a few minutes to plot these points on your graph. All right, so a couple things to notice. Your graph should look like a mirror reflection in the line y equals x. And again, I went ahead and plotted the point 8, 3 because I knew it was a reflection of that. It gave me another point to help me draw a better curve. Also, I used to have a y-intercept at 0, 1. Well, in log functions, you're going to have an x-intercept at 1, 0. And you'll always see that if you plot the original and then plot the inverse. But that's something to notice. And then my next point is at 2, 1. So it's going to go straight from there. Because of the log base 2, my next point is going to be at 2, 1. Another thing which we haven't discussed, but I think you have sort of seen intuitively, is that this one, the original exponential function, has a horizontal asymptote at the x-axis, which also helps us define our domain and range. That our domain for this function, it goes all the way from negative infinity all the way to positive infinity. It's going to keep on going over. So it goes from negative infinity to positive infinity. And the range is from bottom to top. How low does it go? Up to how high does it go? Well, I just said there's a horizontal asymptote at 0. So this one is going to go from 0 all the way up to infinity. And so if we take that same information and flip it, basically, for my log, well, where the first one had a horizontal asymptote at y equals 0, this one's going to have a vertical asymptote at x equals 0. And the domain and range are going to switch. Just because the x and y switched, that also means the domain and range switch. And so our domain now, it doesn't go into the negatives. And we talked about that a little bit the other day on our warm-up. You can't take the log of a negative number because it's not in the domain. So the domain goes from 0 to infinity. Now on my domain, I do have a parentheses, not a square bracket, because it never actually gets to 0. Because let's go back and think about this one. It's going to go down by half, down by half, down by half, down by half. It keeps going down by half, but it never actually gets to 0. Same thing here. It's going to go down by half on my x's, and it's never actually going to get to 0. So we don't have a 0 in our domain. We have it up to 0, but not including 0. And then again, our range is going to go this time. The range is my up and down values. It's going to go from negative infinity up to positive infinity. The main point of that is the domain and the range are switched, and that's what's supposed to happen with inverse functions. Let's go ahead and look at the second example. Okay, the only difference here is that I have 4 to the x. But there should be a couple of other things that are the same. It should also have a y-intercept at 0, 1. The 4 what should happen is it should go steeper. It should stay closer to that y-axis. So let's just see what happens. If we plug in a negative 2, that's 1/16. Okay, my graph isn't great, but notice it's sticking much closer to the y-axis. If I look at my other one, my one up above is going a little bit wider. This one is staying in closer because it has a higher base. Because I'm going up to 2/16, that didn't even fit on my graph to go to 2/16. So I'm going to stick much closer to the y-axis in this case. But again, a lot of the other things are the same. So some of the things that are the same, again, I have a y-intercept at 0, 1. My next point, because of the 4, should be at 1, 4. So it is 1, 4. So that is my exponential function. To come up with the other function, I'm going to have to switch my x and my y. So I'm going to put my negative 2, negative 1, 0, 1, 2 into my y column, and I'm going to fill out my x column, and then I'm going to graph it. Take a second to do that. Okay, so this time again we're sticking really close to the x-axis this time, and the y-axis, of course, we get closer and closer to it, almost touching it, because the 1/16 is my first point. That's really, really, really small. So I have this mirror image again. Let's talk about domain and range. On the original function, the domain is still from negative infinity to positive infinity. The range, once again, starts at 0 but does not include it and goes up to positive infinity. And then the range and domain on my log are going to switch. So let's look at it. From left to right, it goes from 0 to infinity. That's my domain. My up and down goes from negative infinity. This, although it's barely increasing, it is increasing. And the farther we go, the higher it will go. So it is going to go to positive infinity for my range. And again, if you want to talk about asymptotes, the original one does have a horizontal asymptote at y equals 0. And the bottom one does have a vertical asymptote at x equals 0. So these two examples were very, very similar. And that is the way it works. And so all of our exponential functions will have a y-intercept at 0, 1, and then they'll go up from there on the right and down on the left, as long as they have a base greater than 1. And then our log function will just be flipped over, and all of the information will be flipped. The x will go to the y will go to the x, the domain and range switch, etc. But it will have a 1, 0 starting point, and then go up from there and down from there. But look how similar they are as far as the base 2 compared to the base 4. All right, if it was a base 10, it would be even closer. If it was a base E, let's talk about base E. Okay, what would happen to this graph if it was a base E? It would always have a y-intercept at 0, 1, and then what would our next point be? Well, our next point would be 1E. And remember that E is 2.718. So those would be 2 points that we could plot, and then it's going to look really similar to these. And the same thing with the log. The log base E, we call it natural log, but it would have a point at 1, 0, and then the next point would be at E1. It would look very similar to this line, very similar. It's just how close is it to the x-axis. But that's how you would graph the natural log, just like we graph all these others. That is all we're going to do for our notes today. We will work on graphing in class tomorrow.